Welcome to this explainer. Today, we're diving straight into the fascinating world of object-oriented design. But we aren't going to just look at this as boring lines of code on a screen. Instead, we're completely reframing software development. We're going to look at it as the ultimate task of assembling a highly skilled, perfectly coordinated team of experts. If you've ever wondered how complex systems actually hold together without just collapsing under their own weight, you are definitely in the right place.
So, let's kick things off with a massive question. How do developers actually look at a chaotic, messy, real-world scenario and translate it into a sleek, functioning software system? Because, let's face it, the real world is full of ambiguity. It's got changing requirements and a million moving parts. Software, on the other hand, it demands absolute precision and strict logic. Bridging that huge gap between the messy real world and strict logic is the core challenge of software analysis and design.
Well, here's the secret. Really robust software isn't just a giant monolithic block of code that you write from top to bottom. It's actually organized. It's a carefully orchestrated team of fabricated entities. Each of these entities, which we call objects, has a very, very specific job to do. When you start seeing your software as a coordinated team rather than just a massive text document, the whole process of system design completely transforms.
All right, here is our blueprint for the explainer today. We'll be covering 1. The object design process, 2. Essentials of good objects, 3. Structure and control objects, 4. Mastering cohesion and coupling, and finally, 5. The iterative design loop. So, let's jump right into part 1, the object design process, analysis and architecture. First up, how do we actually figure out who we need to hire for our digital team? Well, this foundation starts with the software requirements, truly understanding what literally needs to get done. From there, we move into the analysis phase, where we translate those requirements into static blueprints and dynamic workflows. Finally, we arrive at object identification. This is where we map those conceptual ideas into the actual modules and objects that are going to do the heavy lifting in our system.
Going one step deeper, object design is honestly a lot like running human resources. We are constantly asking fundamental HR questions. We start by asking who does what and who is responsible for what to determine the functional aspects. Then we figure out collaborators by asking, well, who can help with what? Before we finally decide on the nitty-gritty implementation details like data and algorithms. It's exactly like defining roles in a corporate organization.
Moving right along to section 2, essentials of good objects, job descriptions.
Now that we know we're hiring, we need to establish what actually makes a good software object. To do this, we have to completely separate the problem domain from the solution domain. The problem domain is the real world. Think of a physical bank account. But in the solution domain, which is the abstract environment where we build the software, we fabricate experts. So, instead of just a generic account object doing everything, we might create a highly specialized transaction manager to securely handle deposits and withdrawals. We design these solution domain objects to perfectly structure the real-world concepts.
To define an object's role clearly, developers use a classic, brilliant brainstorming tool called CRC cards. That stands for Class, Responsibility, and Collaboration. This tool ensures that an object adheres to the single responsibility principle, which just means it models one thing and does it extremely well, without taking on random tasks outside its expertise.
Think of a CRC card as the absolute ultimate job description. It's incredibly simple, yet super effective. You have the candidate name right at the top, which identifies your expert. The left column lists exactly what tasks they are accountable for, their operations. And the right column identifies their collaborators. These are the other specific experts they need to talk to in order to get their job done. It just keeps the whole design incredibly focused.
All right, up next is section 3, structuring control objects, organizing workflow.
Once we have our specialized team of experts all mapped out, we urgently need to talk about management. How do we actually organize the workflow so things get done? A hugely popular way to structure this management, especially in web and interface design, is the MVC architecture, Model, View, Controller. This structural style cleanly divides responsibilities so your experts aren't stepping on each other's toes. The model is your data engine, the view is what the user actually sees, and the controller is the coordinator bridging the two together.
Now let's look at how this builds a continuous loop in web applications. In this setup, the controller is essentially the manager taking HTTP requests straight from the internet. It delegates all the heavy data processing to the model, which crunches and manipulates the information. The model then communicates with the view, which renders the display right back to the user. Everyone stays in their specific lane, making the entire system super modular and easy to update.
But, just like in the real world, management styles can vary wildly. You might have highly centralized management. Think of a micromanaging boss directly controlling every single worker. Or you can use a decentralized, coordinated control tree. Think of it like using a travel agent. You tell the main agent what you want, and they delegate to local experts who make the highly specialized decisions down the chain. Decentralized control creates a much more flexible and adaptable system.
Let's move on to Section 4, Mastering Cohesion and Coupling, Workplace Etiquette. So, we have our experts, and we have a management structure. But how do these experts communicate without causing absolute chaos in the workplace? Enter workplace etiquette for code. It's best summarized by the law of Demeter, or what we usually call the tell, don't ask principle. Essentially, this means don't rummage through your coworkers' files to find what you need, just tell them what you need done. Look, if you want a television to turn on, you don't write code that reaches into the TV, rips off the front panel, finds the internal power switch, and flips it manually. No way! You just tell the TV object to turn on, and let it manage its own internal components. To keep your objects cohesive, which means they stick strictly to their main job and appropriately coupled, you absolutely must avoid overlapping behaviors. If two experts are competing to do the exact same job, it causes fatal inconsistencies in your system. You avoid this by keeping a core set of essential methods, utilizing static methods, which act like fixed, universal rules everyone can access, and using polymorphism. Polymorphism simply allows different experts to respond to the exact same command in their own unique way, handling variations super smoothly.
And that brings us to our final section, number 5, the iterative design loop, perfecting the team.
Here is a fundamental truth of software development. No team structure is perfect on day one. As requirements inevitably change, your team has to go through an iterative design loop. Think of these like routine performance reviews. You start with your initial domain abstraction. Then, you validate those roles statically on paper and dynamically through live code prototypes. Finally, based on what you learn, objects are refactored, combined, or even flat-out fired from the system to keep the overall architecture robust and adaptable.
As we wrap up this explainer, I want you to think about the code you interact with every day, or the systems you're currently planning to build. Ask yourself this: if your software objects were a real, breathing team of human experts, how well would they actually communicate? Is your system a chaotic free-for-all of tangled dependencies, or is it a beautifully coordinated team? Designing great objects is the absolute key to making sure it's the latter. Keep learning, keep structuring your teams well, and thanks so much for joining me on this explainer.